Let's find the roots. How many roots are you looking for? What's your degree? 2. There you go. We're going to find 2 answers. 2 solutions, 2 zeros, potentially 2 x-intercepts. So let's go ahead and set that equal to 0. Let's go ahead and start the factoring process. X and x. 2 numbers multiply to give me 81. My first thought is 9 times 9. That is going to work. Negative 9 times negative 9 is positive 81. Negative 9 plus negative 9 is negative 18. That means that x equals, let's see, x equals 9, or, all right, please don't write this twice. X equals 9. Oh. Okay, so here's what just happened. We had 2 answers, but they're the same answer. So the fundamental theorem of algebra really does mean I'm going to have 2 roots in this particular case, but they can be the same thing. So now we encounter the situation where if you were to graph this, which we will in a minute, but if you were to graph this, you would see a situation where it touches the x-axis at 9. That's the only place, but it's technically a double root. So if you want to erase one of them, you can, if you're into that sort of thing. And you would say, that's it. And then somebody's going to say, but I thought I was looking for 2 roots. You found both of them. So this is a double root. I'm going to write that down. If you don't write that every time, it's totally okay. But I just want to, for clarification, mention that this is a double root. Okay, I wonder what that looks like. So let's graph it. We're going to go to the graph very quickly. I said very quickly. Here we go. That would be this one right here. Notice that the graph is bouncing off of the x-axis at positive 9. So double roots are going to bounce off of an axis. A double root is really, in a sense, a parabola. Notice that parabola here. Now, I say in a sense because we can have some other stuff going on and it won't fully be curved like a parabola. But in that one little localized area, you might look at it and you say, man, that looks like a parabola in that one little spot. And because of that, there, double root. So I'm going to go back and graph that on the paper. Well, your paper, my board. A double root looks like this. Bounce. Does not cross there, it bounces there. Looks kind of like a parabola. So when you talk about a double root, that's what you're talking about. Okay, let's go to the next one and the next and the next, and you're going to see a pattern here. And that pattern is going to be basically not double roots, but triple roots, quadruple roots, pentuple roots. And you're going to say, oh, okay, I get it now. And you're going to realize what we're dealing with. So here goes. F of x equals x minus 9, and it is cubed. Now, what I was tempted to do when I typed these notes was to give you the full form of this the way it really would have been written out if this was in standard form. This is not standard form. The full standard form of this would be disgusting. 81 times 3, so 243x squared, and then 81x, and then 729. That's not a guarantee that it's going to work out like that. I think it's that. And then we'd have to factor that, and we could totally do that using grouping. Totally could. But just really chose not to because I didn't feel like, wait, something about that feels very wrong. Anyway, that's somewhat irrelevant. Is it? 3. Nope, that's not going to work by grouping. But I think it's right. It's not right. Let's not panic about it. Basically, if I gave you this, yeah, good luck with that. You probably would just resort to graphing. So I gave you this one, which was already in factored form. If I give you something that's already in factored form, it makes it much, much easier for you. So I'm going to erase this. I showed you this, so you would look at it and you would say, what in the world would I do with that? Well, we could try factoring by grouping. But again, this is a lot like number 2 in these notes where you would just say, well, let's just graph this thing, see what it looks like. So a little bit of erasing, and everything's gone. Now it's gone. Yeah, first try, yeah. All right, we're going to set this equal to 0. So 0 equals x minus 9. It is cubed. In order to solve this, now what you could do is you could say, well, I'm going to write this 3 times, and I'm going to have x minus 9 times x minus 9 times x minus 9. Yeah, sure, you do that. You have your fun. I'm going to cube root. I'm going to cube root. Cube root of 0 is 0. X minus 9 equals 0. X equals 9. But you know what? I'm supposed to have 3, right? Because a minute ago when we wrote this out, we had x cubed, blah, 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 blah. The degree was 3. And you can see it here. X is cubed. Yeah? So x cubed, da, 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 da. The degree is 3. I better have 3 answers. And there they are. There's all 3 of them right there. This is a triple root. Okay? Triple root. Written in terrible handwriting. Let's see what that looks like. So let's go to the graph quickly as possible. That was the previous problem, and now we have a triple root. Oh my goodness, that looks cubic. Who knew, right? This looks like a cubic function. This is why we learned all those things at the beginning of the year. Cubic, like that. So if you have the situation where it just sort of looks like it's laying on the axis for a minute, that was bad grammar, lying on the axis, I don't know, whichever. If it's doing that, just kind of briefly, if you zoom in, actually, it does not lay on the axis. It's not ever actually flat, except at one point. That's getting into some calculus and some slopes. But anyway, if it looks like it's doing that, it's probably a cube root. However, hold that thought, it's about to get a little crazy. Just so we'll have a frame of reference, let's graph this one as well. And this is what a triple root looks like. Okay? Looks like a cubic function. All right, let's go to the next one. You can see where this is going. Let's go a little faster. F of x equals x minus 9 to the 4th. 0 equals x minus 9 to the 4th. We're going to undo the 4th power by taking the 4th root of both sides. The 4th root of 0 is 0. X minus 9 equals 0. X equals 9. You know where this is going. I would look at this. If I expanded the whole thing, I would have x to the 4th and then da 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 da. And I don't want da 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 da. I would look at it and just say, my degree is 4. I need 4 roots. There they are. This is a quadruple root. Nah. That makes me grunt. I want to know what a quadruple root looks like. We're going to go to the graph. All right, here we go. This was the triple. This is a quadruple. Now, if you're looking at that and you're saying, that looks like a parabola, you're not too far off. There's the parabola, the black one. And so this one is, sorry, I was looking at the screen here. The battery was low. Hurry, hurry. The parabola, the black one, is bouncing off. And so is the quadruple root. It just looks a little flatter. Now, if you're sketching these by hand, or depending on your scale, it's really hard to determine if it's a quadruple root or a double root, or a 6 root, or an 8 root. It could be an even root, and we don't really know which one it is just by looking at the graph. So later, we're going to get to a situation where we're going to look at a graph and you're going to say, well, maybe it's a double root, maybe it's not, maybe it's a 4, I don't know. But a quadruple root looks kind of like a parabola, and it just looks a little flatter, but again, the scale can throw you off. All right, so before we get too crazy with this, and you say, oh my goodness, I got it already, please make it stop. That should be a 9. We're going to raise it to the 5th power. You know where this is going. We're going to do that. Raise it to the 5th. Let's go really fast. Take the 5th root of both sides. 0 equals x minus 9. X equals positive 9. This is a pentuple root. A pentuple root. Let's find out very quickly what it looks like. And it looks like... You better go. That. Now, if you're saying that looks like the cube root, or not the cube root, but the cubic root, the triple root, you're right. It's really hard to tell from the steepness. All odd roots above 1 look alike to me. And that might sound a little bit like I'm classifying those roots, but really it's hard to tell. So there it is. That's it. There's your pentuple root. So the point of this section of this lesson is to identify what happens when you have a root that repeats itself, and ultimately you're going to have 5 roots, but they're all the same number, and it ends up looking like that, which is really hard to distinguish from a triple root, or a 7 root, or a 9 root.